Good morning, everyone. Today we're going to be learning about rate of change and linear equations. So this should be a review from Algebra 1, but as a reminder, rate of change, it compares how much one quantity changes compared to another quantity on average. It's also known more commonly as the slope of the line, but rate of change is just a fancy word to mean slope. The formula for it, hopefully you remember, M stands for slope. And you can use the change in y over the change in x. The way to find the change in y over the change in x, you have two options. You can either take the second y value minus the first y value and divide that by the second x value over the first x value. Or you can do it the other way around, the first y value minus the second y value, divide that by the first x divided by the second, or subtracted from the second x. You just have to be consistent. So if you do the second y first, then you have to do the second x first. Or if you do the first y first, you have to do the first x first. Something that is important for you to remember is that if you get a 0 on the top, that's okay. It just equals 0. 0 divided by any number equals 0. But a 0 on the bottom, there's no way for that to be possible. You cannot divide by 0, so that's when you get undefined. So depending on the slope, it'll tell you what the line looks like. If the slope's positive, the line is going up or increasing as you look at the graph from left to right. If it's a negative slope, the line is going down from left to right or decreasing. A 0 slope would mean that you have a 0 on top, which means the change in y is 0. So that's why it's horizontal, because the change in the y values is 0, or in other words, the y values are not changing. And then last but not least, if the slope of the line is undefined, that's a vertical line, because that's when you have a change in x of 0. The 0 is on the bottom. That's when you get undefined. And in other words, it would look like the x values aren't changing. So you notice on every point of this line, the x value is always the same. So that's what makes it vertical. In order to find a rate of change, you can do that from points or a graph or a table. So first we'll start out with finding this constant rate of change on the table. It tells us that the table shows the temperature of a solution after it has been removed from a heat source. So you guys have probably done experiments like that in chemistry where you take something off of a heat source and track its temperature. We want to find the rate of change in the temperature for the solution. Interpret the answer in one complete sentence. So whenever you're looking at a table like this, the first important thing to do is to decide what's the independent and what's the dependent variable. If you have time, it's always the independent variable or the x. So I labeled that first, and then temperature is my y, because the temperature depends, or it's the dependent on the time. So then once you label your x and y, you choose any 2 points. If you know that the rate of change is constant, it doesn't matter what 2 points you choose. So I just chose the first two, especially because the first point has an x value of 0. It's going to be easy to calculate with. 0 is really easy to use. Then I write down my formula that we just talked about. I chose to do y2 minus y1, so I know in my denominator I have to do x2 minus x1. And then I'll fill in the values. So for y2, I put 139.4. y1 is 143.6. x2 is 2. x1 is 0. So now you can either do this in your head or use your calculator. That numerator is going to be a negative number. 139.4 minus 143.6 gives us negative 4.2. And then in the denominator, it should be easy because we use that 0. 2 minus 0 is 2. Now this is an easy one to divide. We got lucky. A negative over a positive makes a negative. 4 divided by 2 is 2. 2 divided by 2 is 1. So what this is saying is that the temperature is dropping, that's why it's a negative, by 2.1 degrees every minute. You don't have to put negative 2.1 degrees. That's why you put that it's dropping. Or you could put the word decreasing. But you don't need to put the word decreasing and the negative in there. That would be redundant. You just need to put decreasing by and then positive 2.1 degrees Celsius every minute. Remember that you have to include units in your answer. Now go ahead and try the practice problem. Here's the correct answer for that. Now let's try to find an average rate of change when it's not a constant slope. So you'll notice that these two graphs, the red and the blue, neither of them are straight lines. Only straight lines have a constant slope. So if it doesn't have a constant slope, they'll have to tell you what 2 points to use. Here they told us to use the points from 2004 to 2009. So I'm going to find 2004 on my graph and 2009 on my graph. I'm comparing two different graphs here. So first I'll do digital music, and it might be helpful for you to put it as points first. So I did the X1 is 2004, and when X is 2004, Y is 200. Then when X is 2009, that's my second X, my Y is 3100, that's my second Y. Now I'm going to fill those into my formula, so I'll go Y2 minus Y1 over X2 minus X1. Then you just have to do the calculation. So 3100 minus 200 in the numerator, 2009 minus 2004 in the denominator. Then you're going to go ahead and divide this out. I know that's going to be a 5. Let's see, 2900 divided by 5 is going to give me 580. Now we'll do the same thing for the blue line. When X is 2004, Y is 9.6, so that's my X1 and my Y1. Then, when X is 2009, my Y is 165.8, so that's my X2 and Y2. I'll plug in my values for Y2 minus Y1 over X2 minus X1. I get the same change in X, but my change in Y is different. This time I have to go 165.8 minus 9.6, and I get 156.2. After dividing that by 5, you get the rate of change is 31.24. So to compare these and interpret them, you'll want to make two sentences or so. You make sure that you use the change in Y is on the numerator. So look at the units that you have there. So it's millions of dollars. And then the change in X is coming from the years. That's in the denominator. So it's always change in Y per change in X. So for this one, you can say the sales of digital music increased by $580 million, and then it's per year, because that's per X. If you wanted to actually write that out, it's 580, and then there's 6 zeros after that, between 2004 and 2009. Whereas the sales of ebooks, they only increased by 31.24 million per year in the same time. Now let's work on writing the equations of lines when we have information about it. Hopefully you remember the two forms that are the most common. We have slope-intercept form and point-slope form. The x and y in both of these are the variables, so you just have to fill in everything else. In slope-intercept form, you have to fill in the slope m and the y-intercept b. In point-slope form, again, you have to fill in m, the slope, and a point on the line x1 and y1. For the y-intercept, remember, as a reminder, that is where the line crosses the y-axis on the graph, or in other words, where x is equal to 0. Also notice that in both forms, you need m, the slope. So if they don't give you the slope, that's the first step. So for example, this one, they don't give us the slope. We have x1, y1, x2, y2, but we don't have a slope. So that's our first step, is to calculate the slope. So we'll go -2 minus -1 over 0 minus -4. Subtracting a negative, we're going to be adding, so we have -2 plus 1 is -1. 0 plus 4 is 4. And then if you can't reduce it, you can just leave it as a fraction. This one, it does make the exact value negative 0.25. So if you want to use this as a decimal, that's fine. But if it has a repeating decimal or an irrational number like 1/3, where it makes 0.3 repeating, it would be better to keep that as a fraction. In order to write the equation of this line, it'll be helpful to notice that they gave us the y-intercept. This one, 0, -2, I know that's the y-intercept because the x value is 0. So that's telling me that the b value is -2. So if I have the slope and the y-intercept, I'm going to use slope-intercept form. Y equals mx plus b. I have to fill in m, the slope, so I can put -1/4, and I have to fill in b, the y-intercept, so I can put -2. In order to write this more simply, you can put y equals -1/4 x minus 2, because adding a negative is always the same as subtraction. Now let's try another one together. This one, they gave us the slope and they gave us a point, but this point is not the y-intercept because it doesn't have an x value of 0. So this is the case where I'll want to use point slope form. That's y minus y1 equals m times x minus x1. You'll want to work on memorizing these again if you've forgotten them since Algebra 1. You might find it helpful to label the point x1, y1 so that when you go to plug in your values, you know what's what. We also know the slope is m. And then once you have it written out, you just want to look for stuff that you can simplify. For example, like the minus the negative, you can write that as y plus 2. This is a perfectly good answer because it didn't ask us to put it in a certain form. However, if they did ask us to put it in slope-intercept form, you're still going to start out in point-slope form like this. But then if you want to convert this to slope-intercept form, the steps are to distribute the slope. So we would have y plus 2 equals -4x plus 24. And then you always move over the y1. So in this case, the equation in slope-intercept form would be y equals -4x plus 22. So these two equations, they represent the exact same line. They'll go through the exact same points on the graph. The only thing is, one of them's in point-slope form and the other one's in slope-intercept form. So depending on what the question's asking, they might ask you to convert it to slope-intercept form, but not always. For this one, I just wanted to show you that as an example. All right, now let's do another one. For C, it says write an equation for the line that passes through 4, -7 and 3, -3. So this time, again, we don't have the slope, so we're going to start out with that as our first step. So for this slope, it's going to be -3 minus -7 over 3 minus 4. Minus a negative is the same as adding, so we get -3 plus 7, which is 4. And the denominator, we have 3 minus 4 is -1. 4 over -1 is -4. This time, I wanted to make sure you know that you can use either point when you do point-slope form. So it doesn't matter which point you choose to plug in. Let's just use the x1 and the y1. So we're going to put in -7 for y1 and our slope that we found, -4, and +4 for x1. Minus a negative, we can change to plus, and we get this as our final answer. You could have also used the second point for the point that you plugged in, so it would look like this. You could have done y minus -3 equals -4 times x minus 3, and then you would have y plus 3 equals -4 times x minus 3. That would be a perfectly good answer, even though it doesn't look the same as the other one. If you were to put both of these equations into into slope-intercept form, they would be the exact same. Now I want you to try D on your own. Here's the correct answer for that. I showed you both of the equations, whether you're using the first point or the second point. And notice this time it asked you to put it in slope-intercept form, so you have to convert it. So here's a good example of where when you convert it, it makes it the exact same answer. I just also want to point out you need to be careful on this. Make sure you know that this is not the y-intercept because it doesn't have the x equal to 0. It has the y equal to 0. So that's actually the x-intercept. So don't accidentally put -2 for b. That wouldn't be correct. Okay, now let's do E and F together. These are our last two, just some special cases that you might run into, because you'll notice on this one, when we look at x1, y1, x2, y2, they have the same y value. So if you were to actually calculate the slope, you would have 9 minus 9 over -2 minus 5, or in other words, you get 0 in the numerator. And we know 0 divided by anything is always equal to 0. So it doesn't even matter what the denominator is, it's 0. And earlier on in this lesson, we said that 0 slope is a horizontal line. So it's important for you to remember that when you have a horizontal line, you use the equation y equals the y-intercept. Or in other words, you're just going to look at whatever the y value is for every point is the y value that you have in your answer. So this one's just y equals 9. Similarly, for the next problem, they have the same x values. So you'll notice that if you were to calculate the slope, you would have 8 minus 7 over 2 minus 2. You get 0 in the denominator. No matter what the numerator is, if you have a 0 in the denominator, it's undefined. Earlier in the lesson, we talked about how an undefined slope means that it is a vertical line. Vertical lines are always represented by the equation x equals the x-intercept, so you're going to take whatever that x value is in all the points, and that's going to be the number in the equation. And keep in mind, when it's vertical, it's x equals, horizontal is y equals. So that wraps up our lesson for today. In the next lesson, we'll keep working on equations of straight lines, but we're also going to work on equations where the lines are parallel and perpendicular, which I know you learned in Algebra 1, and hopefully you reviewed it again in geometry, but we'll go over it again together. Talk to you guys then. Bye.